So students, in our last video we studied about what is shear force diagram or SFD and what is bending moment diagram and or BMD. So in this video we are going to solve one problem where the point load is subjected to a cantilever beam. In my last video also I told to you, cantilever beam is nothing but it's a beam which is fixed at one end and free at another end. And point loads are the loads which are acting, point or concentrated loads are the loads which are acting at a single point. So here you can see, here it is a beam, it is fixed at one end and free at another end, and it is subjected to 3 point loads. One is 10 Newton, another one is 20 Newton, and another one is 20 Newton, and each are 2 meter distance from each other. So in this case, if this is the beam, what will be its shear force diagram and what will be its bending moment diagram, that we will calculate. So for calculating purpose and for our easiness, first what we will do? First we will give the names to the salient points. Salient points means what? These are the points where the value of shear force or bending moment may change. That means, see here, it is the point where a load is acting. That means definitely some shear force and bending moment will act. And again it is another one point where another 20 Newton force is acting. That means what? Definitely whatever the shear force or bending moment was acting at this, from this point to this point, definitely here it will change. Why? Because of extra addition of 20 Newton force. So like this, wherever there is a force or a reaction is there, those points are the salient points, and we will name those points. So in this case, let us name it as point A, name it as point B, C, and this is point D. So for calculating, we will break them into sections. First one is section AB, for section second one is section BC, and third one is section CD. At individual section, we will find out the shear force and bending moment at all the salient points. That means if I am taking point AB, here the salient point is A and the salient point is point B. I will take the section AB, I will calculate the shear force and bending moment for point A, and I will calculate the shear force and bending moment for point B. And I am not calculating the shear force and bending moment for the mid region. Why? Because there is no force or no support is there. So definitely there is not going to be any change in the shear force or bending moment in the mid region. So let us first take section AB. So for this purpose, what I am doing, I will consider a section XX at a distance of x from A. Let us consider a section for section AB. Let us consider a section XX at x distance from point A. And now draw this one. Just forget about these things and only draw this much. How it will look? It will look like this. This is the section XX, and this is the point A where 10 Newton force is acting, and this distance is x. I have considered. So now find SF at x and BM at x. So what will be SF at x? See here, how much amount of load is acting there? 10 Newton. Okay. And I had told you run, are you on right side? If right side is going upward means that will be negative. This is the right side of the beam. Because of this 10 Newton, this much portion of the beam, whether it will go upside or downside, definitely it will go downside because the force is acting in the downward direction. That means right side of the beam going downward, so this will be positive. So plus 10 Newton. And what will be the bending moment? Bending moment is nothing but force into perpendicular distance, 10 into x, 10 into x. Again, bending moment is a vector quantity, so we need to find out its direction. What I have told you, if because of this force, how the beam will bend? The beam will bend like this. I told you, if it is forming a shape of that, then that will be negative bending moment. So definitely the direction will be minus 10x. Is it clear? And this is the shear force and bending moment value at x. But I don't need at x. I need at point A and point B. So if at point A means point A, x cross section is at x distance from it. That means A is at how much distance from it? That means x value at A is 0 and x value at B is 2. So at A x equal to 0 and at B x equal to 2 meter. Now put here SF at A, this is independent of x, so plus 10 Newton. SF at B, as it is independent of x, this is also plus 10 Newton. Now BM at x is equal to minus 10 into x, that is minus 10 into, here x value is 0, so 0 Newton meter. Similarly, bending moment at A, here this one. Bending moment at B will be minus 10 into x distance x, that is minus 10 into x equal to 2, that is minus 20 Newton meter. Now draw that one here. Shear force at A is 10 Newton, suppose this is 10 Newton, and shear force at B is 10 Newton, this is 10 Newton, 10 Newton, and bending moment at A is 0, bending moment at B is minus 20 Newton meter, this is minus 20 Newton meter. And also now I have an option, I can draw a straight line from here to here, or I can curve it. Now the question is that whether it will be a straight line or it will be a curve. So from here you can get that bending moment, the formula is 10x. You know that straight line equation equal to y equal to mx plus c. As long as x to the power 1 is there, then definitely that will be a straight line. So here is x to the power 1 is there, so definitely from here to here in this graph, the line will be a straight line. So this is the shear force value from the section A to B, and this is the shear force value from the bending moment value from the section A to B. Now similarly, A to B equation, now to see B to C. For getting B to C, similarly draw the section XX in between B and C. This is the section XX at a distance of x from point B, and we will find out the shear force and bending moment at XX. Then we will equate that one to B and we will equate that one to C, so that we can get the shear force and bending moment value at B and C. Now let us draw the diagram, how it will look. Let us consider a section XX at x distance from point B. So now draw it. This is the XX cross section, and this is the portion of the beam where this is the point A, 10 Newton force is acting, and this is the point B, 20 Newton force is acting. This distance is 2 meter and this distance is x is a vector. So now shear force at x, how much it will be? 10 Newton, and this is making the right side of the beam downward, so positive. Previously also we had seen. Similarly 20 Newton is also making the beam going in the downward direction. Right side going downward means this is positive, so plus 10 Newton plus 20 Newton. There is no change of sign. Similarly, bending moment at x is equal to 10 into this distance, 10 into 2 plus x, and this is making a hat shape like this. So this is negative minus 10 into 2 plus x. Again, because of this 20 Newton, it will bend. Similarly, it will bend like this. Again, this is also negative because the direction is same as the previous one. So minus 20 into x. This distance is x. So now solve it. This is minus 20 minus 10x minus 20x. This is minus 20 minus 30x. Now see, at point B, x equal to 0. At point C, x equal to 2. So put here at point B, at B, x equal to 0. So SF at B will be plus 30 Newton and DM at B will be, that is minus 20 minus 30 into 0, that is minus 20 Newton. Okay, similarly at C, x equal to 2. So SF at C, as shear force is independent of x, so it will remain same in both the points B and C. And bending moment is depending on the x, and the x value is changing. X value means the length of the beam is changing. So bending moment value will change from B to C at each and every point. So that is SF at C equal to plus 30 Newton and BM at C is equal to minus 20 minus 30 into x, and x value is 2 minus 30 into 2. This is 60 and this is 80. This is 20. This is 80 Newton. Now draw that one. Here at point B, in the previous case the shear force value was 10 Newton, and at this case the shear force value is 30 Newton. Why this much of increase is there? This much of increase is there because of this 20 Newton force here. So here the shear force value will be 30 Newton, and at point C also the shear force value is 30 Newton. So we draw a straight line like this. Here this is 30 Newton. And bending moment value, previous case also it was minus 20 Newton meter at point B. In this case also the point B minus 20 Newton meter, so minus 20 Newton meter. And at point C, that is minus 80 Newton meter. So this is the point where minus 80 Newton meter is there. Again the question is that from here to here it will be a straight line or a curve. You can see here there is no second power of x, only 30x is there. So again it will be a straight line because of the equation y equal to mx plus c. So again from 20 to 80 there will be a straight line. So we got the shear force and bending moment up to point C. Similarly, we will take another one section xx between C and D, and we will get the shear force and bending moment at point C and D again, so that our total shear force and bending moment diagram will be complete. So now for section CD, let us consider section XX at x distance from point C. That means take a section, now erase this one and take a section XX here at a distance of x from point C. So now how the diagram will be? The diagram will be in such a manner that this is XX and this is point A where the Newton force is acting, point A, and this is point B where 20 Newton force is acting, and this distance is 2 meter. This is point C where again 20 Newton force is acting. This distance is also 2 meter, and this distance is x meter as we have taken here. So at XX, SF at x is equal to how much? 10 plus 20 plus 20, because all these three forces are making the beam in the downward direction, making the right side of the beam in the downward direction. If the right side of the beam is going in the downward direction, means that will be positive. So plus 10 plus 20 plus 20, that is 50 Newton. Then bending moment at x. See here, as all the forces are in the same direction, so directions will always remain same. So bending moment because of 10 Newton is nothing but 10 into this distance. This distance is how much? 2 plus 2 plus x. So 10 into 4 plus x, and again the direction is like this. So this is negative. So minus 10 into 4 plus x. Similarly 20 into 2 plus x plus 20 into 2 plus x plus 20 into x. That is the force at point C. So solve this one. Minus 40 minus 10x plus 40 plus 20x plus 20x minus, no, these are minus, 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 so minus 40 minus 20x, again this is minus 20x, so this will be minus 80, minus 40 minus 50 minus 80, minus 10 minus 20 minus 20, that is minus 50x. Now we got this shear force and bending moment at xx cross section. Now for point C x is 0, for point D x is equal to 2. Just put this one just like our previous case and you will get shear force and bending moment at point C and point D. So at point C, x equal to 0. So SF at C is equal to, same it will remain same because it is independent of x. So SF at C equal to 50 Newton and BM at C will be, that is minus 80 minus 50 into 0. So 50 into 0 is 0, that is minus 80 minus 50 into 0, that is minus 80 Newton meter. Similarly, at D, at point D, x is how much? X equal to 2. At point D, this distance is 2. X equal to 2 meter. So SF at D, same 50 Newton. PM at D is minus 80 minus 50 into 2, that is minus 180 Newton. Now let us draw this one. Previously at point C, how much this shear force was there? 30 Newton was there. Now for cross section, for section C and D, we are getting this one as 50 Newton, and at point D, we are getting this one as 50 Newton. And bending moment, previously we are getting as minus 80 Newton per meter. Here is also minus 80 Newton per meter, and point D, that is minus 180 Newton per meter. Minus 180 Newton per meter, like this. Now just highlight this one. This is the shear force diagram of the beam, and this is the bending moment diagram for this. Again, this will be a straight line because here h to the power 1 is there. Again, this straight line formula y equal to mx plus c. Just because of that one, this will be a straight line, and the bending moment will be 190 Newton per meter. And this is the shear force diagram, and this is the bending moment diagram. Like this, we used to solve the problem of the shear force and bending moment diagram of a point load, of a single point load or various point loads acting on a cantilever beam. Thank you.